fix cars. It's actually a fascinating industry. So, yeah, so I'll be talking about Shiny. It's a little bit of a, was anybody else talk last year? Okay, so it'll be a lot of repeat for you, unfortunately, but it's a little bit of a fringe talk. I felt weird. They asked, I'm a co-organizer of the Twin Cities R user group as well, and to come to something like Google Dev Fest. I'm not a programmer. I'm a mechanical engineer, so this is sort of just a hobby side interest of mine. I really enjoy programming, but just with the job that I do, I'm not a web developer. I have time to do things like this all the time. So, so this will be mostly an intro. We'll focus more on examples just to try to show you what Shiny can do and hopefully entice you to perhaps play around with it. Just out of curiosity, how many people have used R? So maybe like a third. Does anybody have never even heard of R? Cool. So yeah, so I added some stuff because I feel like you can't talk about doing interactive graphics with R, this sort of maybe clunky or pretty odd language, I think. The syntax can be a little bit odd for people at first. It has some odd nuances to it that at least were confusing to me. Maybe that's just because, again, I'm not a programmer, so I don't have a ton of languages. I just took a Java class at St. Thomas where I went to college in mechanical engineering. And really at its heart, it's for statistics. It's a statistical programming language, I guess is how it would define itself. And I feel like R has a little bit of a reputation like Emacs. Like it's just this really heavy, can do anything. There's so many add-ons and packages and libraries, so that can make it maybe not as friendly for something optimized. Like for example, I've heard Google uses R pretty heavily for early development, but they're not going to scale something up in R. They're going to write it in Python or whatnot. So for me, this just was a nice fit because I feel like with my programming inclinations, I love trying to integrate some of that into my job as much as I can because it's sort of a cheater way to build a new skill while still getting my work done. So at 3M, Minitab is sort of the statistical program of choice or what they provide. But I like to use Linux as much as I can, and I just hated, I don't like working with binary files and store most of my data in CSV, and so I don't have the need for Minitab, nor do I really like just having to fire up Minitab, say every time it sends me a file, or if I want to do an analysis for somebody, having to do it in that context. Cross-platform consistency, so if I do have to use some fringe application that 3M still only allows Internet Explorer to work for, and I boot into Windows and I don't feel like rebooting back into Linux, I can fuss around in Windows and do the same work, and it works. There's some really great plotting libraries, which is a lot of what I do, collecting data and then trying to summarize it for a team to make decisions. Love the data manipulation, so I think when I first started that stuff can be a little bit harder to get into, so I was mostly interested in how do I represent data visually, and so I would do all my manipulation in something like Excel, get the data in the right format, but then as I picked it up, R can do some, I think they're pretty ridiculous things in terms of, well, that would get too into, but those packages and functions are awesome, so Melt and ddply, for example, are subsetting particular sets of data frame according to criteria, and like I said, there's a very large package repository for doing various statistical techniques. So it's for statistics, but why in the world would you use it for web graphics? So again, maybe this is a fringe thing that only applies to me, but so I learned this language, and now RStudio released a library called Shiny, which lets you do interactive web graphics. So for me, it's a bonus because this is really the only programming language I have developed some proficiency with and use on a daily basis, so even better that I can just leverage this library to make web graphics rather than something like D3, which I love and would want to learn someday, but just realistically I don't have as much experience, whereas R I get to use all the time, so I'm a lot more familiar with it. So that may not resonate with you to pick up a new language just to do something you could do in JavaScript if you already know it, but for me that was kind of a nice niche. So I find it really nice for prototypes, visualizations and sketches, exploratory analysis, which I'll show you some examples of. So I'll just dive in, I guess. So like I said, I think that covers that. This is on GitHub. I don't care if you go now and want to clone stuff, or feel free to play around. I won't be offended. But it is on GitHub, and so is last year's version. Last year was a sort of a combined talk where I showed how to use some geospatial data in R as well, which is pretty neat. So it has some nice tools for getting latitude, longitude, coordinates, or extracting maps from Google. That actually seemed like a better fit last year because you can leverage the Maps API and get snapshots of different zoom levels and then overplot with ggplot. So unfortunately, you can't. So I start talking about R because you can't do anything in Shiny that if you can't do it in R first. So if you're familiar with something like Spotfire, where you just load in, it's another statistical visualization application. So if you load in a file, it kind of gives you this intuitive, maybe a drop down for every column of your data. So you don't really have to do anything. You just say, here's the data, and it will sort of try to interpret how you might want to visualize it. And you can choose the chart type. Oh, I want to make a scatter plot or bar chart with, this as the X variable, this is the Y variable, or ggobi is another similar one like that, where it's just sort of doing the exploration for you. So Shiny's not like that. You're just taking R code that you would write locally and adding some interactive features to let the user interface with it. So there's two main files you need, and I think this may be outdated. I believe I've seen sort of a nested setup now where you can kind of write it all in one file, but this still works, and so that's what I'm sticking with. You're going to need R. You're also going to need RStudio, which is how Shiny runs. So that's what you would do to install those. And this is on a minimal UI, so this is going to define your user interface side. So it's going to set up a page. You've got some sort of a title. There's usually a sidebar on the left where you're going to have your inputs, the things that the users can interact with, and then some type of output. So if it's a plot, it's plot output. You can do tables that update dynamically if you're changing the data that the user is selecting. And there's lots of these. They're really well documented on the Shiny webpage. And then your server file is going to do sort of all the back-end stuff, data processing. What did the user select? Okay, extract a subset of the data based on that, and then create the resultant plot. So if you use those minimal files, you get something like this. Not too exciting, but we have our sidebar. We just didn't define anything to go in it. And this is, on the right, is the area that your plot would appear. So there are lots of choices. So most of your standard HTML type inputs, checkboxes, whatever. They've got file uploads now. I haven't played with that, but that's pretty neat. There's some catches there where maybe you'd have to account for what format the user's data is in, but if you specified that, they could upload their own file and then leverage your tool to explore it in that way. And then there's lots of outputs types as well, so not just plots. Like you said, you can have tables or images or even rendered Markdown or HTML. So here's one example. I was going to that. So I found some transportation data. There's a sister site of Stack Overflow called skeptics.stackexchange where people will just post questions like, usually in the form of, does X really mean that Y, or does this imply that, whatever. So somebody posted this question, is public transportation really more efficient than most people driving around? And it seems like, well, of course it is. Buses would be a better way to go, or trains, or any type of mass transit should be more fuel efficient. And so I got curious about that and thought, okay, how to answer this question. Turns out there's some really cool data out there from the National Transportation Database, and they collect statistics from all of the public transportation organizations in the U.S. about how many passengers they had on average, what type of fuel they use. Some are on electric, some are on biodiesel, diesel, whatever, and how many miles they travel, what population they serve. It was a really interesting data set. I started trying to explore, but it's huge, and it's not apparent what the relationships might be. So you could do some maybe linear models to try to figure out correlated variables or whatever, but mostly I put this together for the talk, but I thought, okay, this would be one cool way. Could I make something where you could sort of look at X versus Y combinations interactively rather than maybe having to iteratively generate all these plots just to try to see what you're dealing with. So the link there, I think, is to the question on Stack Exchange. And at the time, I had done it in Excel just with a simple bar chart summarizing by state. And it turned out there's only 5 states on average that are better than the average single car or occupancy, if that makes sense. So they have statistics on that too, of how many people drive singly, 2 people in a car, et cetera. And So the measurement is BTUs per passenger mile. So how much energy does it take to move one person 1 mile? And if you compare that on state averages, they're actually pretty bad. So I got curious, like, why is that? You know, and I would have expected maybe California and New York to do awesome, where you have really defined infrastructure. But it wasn't that simple. Minnesota is actually like the last one before the cutoff where cars are. So now you need the internet to play along. So this is what I wrote. So it's got the data loaded in the background, and I just made some simple drop downs. So these represent all the columns in my data. So right now it's not very interesting. We have population versus population. So you get a linear relationship. The variable I'm generally interested in is this BTUs per passenger mile. So now we get a plot there, and there's some outliers. So that got me interesting. You know, you can pass ggplot, which is the plotting library that's being used here. It has built-in parameters to accept scaling types. So you know, you can apply a log scale to sort of spread everything out. You can also pass it some variable to use for the color. And I'm using one that I kind of know there's a relationship. So this one, you know, I find pretty interesting. So the higher it is, the less efficient it is. And these are going to be a little bit confusing. I don't even remember what they all are for now, but I know for sure like VP is Vanpool. So you can see most of your pink is definitely at the lower end of the spectrum. But this is just an example of where you could play around with different combinations or different, you know, you could add a size variable in here. I tend to find that seems to like clutter it up a little bit, and there's a little bit of difficulty with adjusting your relative min versus max size range appropriately. So I'll just leave that out for now. But you know, van pools are down there, and they're, you know, that's an interesting thing. So van pools tend to be somebody's picking up a group of people at a gas station, driving them directly to the destination, returning them to a common drop-off point when they leave. So maybe some missing aspects of the data is how far did each person drive to the gas station first, for example, the pickup location. And buses are just all over the place. So, but it's pretty, you know, I find it flexible and just a way if you have a complicated data set. I guess one of the examples I just want to highlight is how you could use this for kind of personal initial exploration, then maybe you find a couple relationships that you want to pursue further, or it saves you from having to write every permutation of linear model just to look, whereas visually it can stand out a lot more clearly and more intuitively. So that's one example. Another one, I was working with some machine learning on tape data, trying to apply to adhesives, and you know, you end up with all these predictors and a couple of responses, let's say. So a common test is put tape on a piece of glass and peel it off at a known rate and measure the force. It's kind of your stickiness value. And there's a lot of inputs that go into that. What's the molecular weight of the adhesive? What type of adhesive? There's different components in the adhesive. And so you can end up with, it's just hard to portray all of those variables in one place. So if you want to simulate what it would be like to vary input 1 and input 2, maybe you have 4 other predictors, you need to hold those constant at some value to do something like a contour plot, because those aren't shown. So those are going to be fixed, and then your axes are going to show the relationship between 2 predictors and the output. It can also be difficult, you know, as I was generating static plots, how would I share this with my colleagues without having to send them like 100 plots and talk through it or whatever. So this isn't the real one, but I posted on Stack Overflow about how someone would make an interactive contour. I forget the exact challenge that I ran into here, but this maybe look better. So, and you can change the plot type as well. So these are just things that are being passed to ggplot in the background. You know, more typical contour plot, I guess, or a tile map, as ggplot would call it, or heat map, however you want to look at it. So what I liked is, I was actually trying to replicate a different piece of software called iSight, which is used for this sort of thing. And it had these sliders, which I thought were kind of neat. So if you find an area that looks more promising with your desired output, so if we just assume, okay, I want my response to always be red, you can start tweaking those sliders and say, well, I can ignore everything where, you know, if I look at this, y would be x3 here. I don't really need anything that low, so if I slide this up to tighten it a bit, I'm assuming that'll get more red at the bottom, fingers crossed. I haven't played with this in a while, so okay. So why kind of spend your time looking outside the ranges that don't make sense? Anyway, I just find it neat because you can change what the fixed value is. So anywhere that x1 is not on an axis, you need to set what the other, what the formula is going to be with that held constant while varying other of your inputs. So it's just another way to have a lot of data in one place and not have to just constantly kick out all these plots. A new one, this is super new to me. I literally just put the example together last night, but there's a guy, Ramnath V. I only know him by his GitHub name, but he's been doing a tremendous amount of cool stuff, and R charts is one of them. I'll just show you the website. So what he's done is taken R, so Shiny is sort of a front end to allow you to use R for web graphics. He's taken R and allowed you to have access to all these existing JavaScript plotting libraries. So you can still write, if you know R, this is a very R-ish plotting syntax. And in the background, he's converting data to like JSON format and then accessing the JavaScript libraries that exist. So now, this is embedded in the page and you're getting some interactivity. You can hover, so that's polychart. And that kind of gives you these, R would call it facets. So you're always plotting the same X, Y variables, but you're grouping by some other characteristic of your data. This one I think is more for time series data. I haven't played with that one. And you can get some nice visualization. And there's nothing that specifies I want it to animate. It's just part of the NVD3 library. So I find that pretty neat. Again, maybe not your thing, but I'm coming from not being a big JavaScript guy. So for me, that's really cool. Like, oh, I've got a new tool that I can use with minimal overhead. There's a caveat in that if you start wanting to customize this too much, I don't think he's gotten to the point of converting every bit of our option into its analog in the library. So you do have to kind of look at the documentation for the library if you start wanting to pass sort of more internal specific parameters. I don't have a great example of that because I've literally just started playing with this in the last week. But hopefully that makes sense. You might have to get into DOM elements or just more CSS-y type stuff if you want to start customizing. But out of the box, it's pretty cool, and you can, if I remove one of these, you get some auto scaling of the axes. Or it should have done that. I assumed it would. So that's pretty neat, and you can also embed them in Shiny. So maybe that seems a little redundant, but I'll show an example here. So I have a piece of test equipment, moves at different rates. I had a custom machine builder, so I specified I worked with them to build it. And we got it in, and I wanted to know for sure when I punch in what rate I want it to run at, what rate is it really running at. So I got a laser sensor, which is fun to play with. Generally, these are just ridiculously long, sampling 2 microseconds for every time that it was moving. And I just wanted to explore what does it look like, how consistent is it, what's the overshoot as it ramps up to speed, etc. And there's a ramp mode as well, so it's supposed to have sort of a min and a max speed and then accelerate through that. And I'd be watching this thing and testing tape and thinking it can't possibly be constant acceleration, but I didn't have the data at first to know that. And the guy who programmed it, he didn't quite know either. He said, oh, I just know there's an option to do this ramped mode. So I got the data, and yes, I could generate a lot of static charts, but this one, I don't know why that times out. And this is a big data set, so it takes a little bit longer. And I'm actually only sampling in the background, I'm sampling every 250th row, so I'm cutting it down pretty big. But if I play along. So if I just plotted all my data, because I'm looking at, this is time down here in seconds, and then this is the speed that this particular machine component is moving at. if I plotted it all like this, it's just hard to see things relative because the shortest speed is like 0.5 inches a second, and it's moving about, so just say 15 inches. So 30 seconds versus the fastest speed is about a meter a second, so half a second for my hold time. So they're so difficult, so I was looking for a way to group them. So starting in the background, I'm defining what my groups are called. What I'm thinking is the slow group, and I can also switch on and off the ramp or constant set because I label them in my data. So for every row, it says whether it's part of the ramp mode or the constant mode. And again, I can go in there and extract. I've got an initial acceleration, so I can figure out what that is, and then maybe decide I want to take from the 20th to the 80th portion of my data and take the mean of that to figure out how consistent it is. But for an initial, not too hard to plot example, this just lets me kind of get a sense of, okay, 1.09, 0.91, okay, plus or minus maybe 10%. Also with and then this is where I've got the shiny inputs that help, but also I get to get the little clickable on-off stuff for free as part of NVD3, which is going on. So that's kind of a neat way to mix both the JavaScript aspect of the library as well as the shiny. And just to show like one insight. So I said it wasn't constant acceleration, like it's not. There was this definitive lines. And the more interesting thing to me, this actually let me give input back to the machine builders of, okay, both of these, you actually input 4 speeds, and they're all equally spaced in this case, but for some reason, however he's got this programmed, they're both ramping to that first speed over the same amount of time and then taking off from there. So I don't know why that is, but I'm assuming maybe by telling him this, he can go in his mind and think, oh, okay, I know why that is, and fix it. But I would not have known that intuitively or how this is behaving. So that's been kind of fun, I guess for me. I haven't used it a tremendous amount in depth, but I just think it's a neat library that I hope to explore a lot more in the future. And maybe moving on, 3M's got some internal hostings. I think again the shareability aspect is pretty neat. And you don't even need Shiny in this case. You can use RCharts by itself and just send somebody a HTML file or host it. So that's more on the work side, and this is like my prized Shiny development. So I got really interested in, well, I've always been interested in analyzing things and trying to come up with a conclusion. And benefit plans, like initially, I don't know, that I just didn't think about it too much, and then it struck me, these are actually sort of complicated to figure out. It's not intuitive, when you see, here's your deductible, here's your premium, where's the cost-benefit analysis of how to get the most bang for my buck, kind of. So 3M releases these every year. Here's what the plan criteria are. And I wanted to, I get in discussions. At first I was doing it in an Excel spreadsheet, and I kind of knew, okay, pretty sure this one plan is like never advantageous. I don't even know why they offer it. But it's the lowest deductible plan, so I get in conversations with other people and try to sway them and say, well, I simulated all these ranges of possible expenses, from nothing up to like $50,000, maybe if you had a surgery, and this one plan is never better for you, and you just can't wrestle with, yeah, but it's got a $500 deductible, and this other one is $2,400. Like, how in the world is that better? So visualization, I find, can kind of cut through that and just let somebody look, hey, here's all the data, here's the formulas they used, go for it. So, yeah, you usually get something glossy in the mail, looks really pretty, and maybe here's a theoretical criteria. So you have different premiums per month. 3M may, in some cases, contribute to an HSA, so you get some free money to apply towards your health care. The deductibles are pretty different, and the out-of-pocket maximums aren't that different. Which one's better? And I don't know that many people could look at the chart and figure that out. So, and they always have a picture like that too. how happy it is to make a benefits choice. And it's not been my experience that most people look like that when they're thinking about these things. So back then, we have a pretty simple case. We know the relationship of before you hit your deductible, you're paying in full. Then in the next phase, 3M's covering everything. In my case, at 90%, is what the plan does. And then once you hit your out-of-pocket maximum, this is scaled in a little bit, but there would be a part where that plateaus. Your costs don't increase no matter how far on the right axis or on the x-axis you go, which is what I'm calling sort of what they tell you to pay. So you get a bill for some service, but you're only paying 10% after your deductible, and then at some point you won't pay anymore. So 2 years later, now they have some plans with these split criteria. So there's an individual deductible. Let's say you're on a family plan. This wouldn't apply if you're just an employee. But you're on a family plan, and if one person hits half of the total deductible, that person is covered at 90%. But the other members of the plan have to make up the remaining half of the total deductible. And if it sounds confusing, it is. So now you have some multi-variable stuff going on, multiple criteria. You would need to check, if you're trying to simulate expenses, I can't just plot them over the whole range. I need to know, well, what do you think the top spender would spend? And is that person above the individual deductible? If so, he's covered. But do the other people match the second half? If they didn't, then they're going to keep paying in full. And if they did, then everybody's covered now at 90%. So before the world of Shiny, I thought, okay, multiple variables, contour plot. So on the bottom axis, I have what the highest spender would pay, and on the y-axis, I have what everybody else would pay. And so you can kind of imagine you're climbing stairs. So this is sort of like a side of stairs kind of coming up together. So if you just go to the right, you're rising at, you're paying in full, and then you hit the deductible. And now this person, your highest spender, you can see the lines change from this to this. So now he's only going up at a 10% slope, whereas everybody else is going to have to climb up to this plateau here before they hit 10%. And again, if that's confusing, it's because it is, and contour plots sort of suck at visualizing something like this. So I thought, okay, well, there's 3 plans. What if I took all the contour plots, like imagine mountains with different topography, and you could stack them all on top of each other, and for everywhere in your surface, let's just find the lowest point, and I'll color it that color. So we have plans A, B, and C, and now based on your combination of who is going to spend the most in your family and everybody else, you can find an XY point and say, that's the plan that's best. And this A plan is kind of the one where I suspected it's not really ever advantageous. It turned out I was wrong. There's a little island where it's quite nice. But it's pretty high, so maybe most people wouldn't be interested in that range of thinking they'll spend $20,000 to $30,000 in a given year. So then Shiny comes out, and I see it for the first time, and I think, this is it. I got to do this. Because I was already wrestling with that here. You can see which plan is the best, but a lot of people want to do a little bit of a risk analysis. So let's say I think I'll be here, and really I end up over here. How bad is it that I'm in a red zone when I thought I was going to be in a green zone? And so there was a library at the time called Playwith, where you could sort of run it locally and hover your mouse, and it would maybe give you some points. But it wasn't great, and definitely not shareable. I mean, somebody would have had to install it, know how to use R, and get going that way. So I wanted to cover all the plans, so even though I just do employee versus family, and definitely it's something I like doing to try to help other people make this decision, because a decent chunk of change that's involved. So I want people to be able to say how many people are on your plan, what type of plan, because there's employee, employee spouse, employee plus children, and then employee plus family. And thankfully there's sort of an analytics group in 3M, so they had an instance of Shiny Server, so I was able to host it inside the firewall, I guess. I don't think that should be necessary, but HR seemed sensitive about revealing like what their plan coverages are. Anyway, yeah, which again, it's not confidential. Like because I inquired, can I present this at an R meetup group? I said, oh, that's kind of confidential, and I responded with, well, should I hide the documents you send to my house from my wife because she's not a 3M employee? You'll send it to her. So So that was internally, and then I kind of anonymized some values and just tweaked them a little bit and put it on Shiny apps, which I'll talk about in a little bit. And this is why it's complicated. So there's, kind of went through and had to figure out what are all the different permutations of cutoffs that somebody would have to satisfy. And that was just how I thought about it, was in sort of this table of, okay, did you know, going down each column, did you meet the individual deductible? Did you hit the individual out of pocket? Did the rest of your family meet the remaining deductible or the remaining out of pocket? And then did the total group hit either of those criteria as well? And those are sort of the unique cases. So I posted this, again, I rely on Stack Overflow a lot when I'm out of my element, and I said, one year I did this all in just if-else statements, and it was absolutely horrible. And I said, what would I do different? And somebody said, oh, what you've got looks sort of like a truth table. And somebody at some point mentioned binary, and I thought, okay, that's interesting. Like each row, if you treat it like a different 2 to the column number, you get a different sum, a unique sum of results. So what I did is, you know, created this is just a vector, if you're familiar with that, or just literally like a list of, you know, think of it as different cells in a table if you're not familiar with that. So I needed 2 each, so 2 for how much the individual is going to spend, how much the remaining people were forecasted to spend, and then how much the total spent. And then I compared that against the different cutoffs, so these would be specific for the plan that I'm looking at. And then, I don't know if this is probably possible in other languages, but ours may be somewhat neat in that you can be a little bit liberal with your variable classes. So when I compare this test case and to see if it's above the limits, I'm going to get a vector of true-false data. And maybe other languages are like that too, but ours is cool with thinking that it's just 1 and 0, so you don't have to do a secondary step. And this is sort of just a matrix multiplication of 2 to the power that I want. So super ugly, but this is a hacky way to define, you know, for each of those binary unique numbers I'm going to get, I've defined a function that corresponds to it. There has to be a better way, I'm sure. But in R you can just have lists and they can contain whatever. So this is a list of functions, and when I find my binary sum, I say, well, which function corresponds to that? You know, the number 17, and then I can call that particular function for that criteria. So yeah, enough about that. Oops. So this is what I came up with. There's still some aspects of it I'm not super happy with, but for a first go, I was pretty happy. So you can choose your plan type. So I'll just go with the employee plus family. There was a link, I think, on a previous slide to dynamic UI elements. So right now, if we just look at what's available, you can, this will also come into play, so you can have an amount come out of your paycheck tax-free that goes into an HSA or an HCRA. And right now you just have that. You know, for most people, I was thinking this just sets the max of this slider down here. So for a lot of people, maybe $5,000 is a reasonable limit. But if somebody knew they were having a surgery, that wouldn't be possible, so you'd want to kind of bump up, like, what are you able to say is the max down here. I left it at 5,000 because I don't know how to scale the spacing, and it can get a little cramped to try to be grabbing 2 sliders when they're so close. So I'll just leave it at that. And if I choose employee and family, now it says how many people are on your plan. So I'll just say 3. And now again, I've popped down a slider for each person. So whether that was the best route or not, but I just thought it'd be fun for people to kind of just go in and rough it out, you know, because nobody really ever knows what they're in for. And you can say, well, most of the time I spend nothing, but if I do the worm while drunk at a wedding and bust my chin on the dance floor, need some stitches, that never happened. Maybe I'll be looking at like $1,500, you know, for an ER trip or something like that. So you can kind of account for some variability. And again, some of this is a little rough with how you set, because this is set a little bit manually, what your tick values are. So sometimes it can get a little bit cramped. And let me just make it a little more interesting. Okay. So in each case, in the background, I'm taking the left slider value for all the pairs, and I'm running through my criteria. And for each plan, I'm showing you the premiums never change. That's just what it is for the plan. The red are are what you would have to pay. So that's your total for the year. So you're gonna not see really and that's another thing that people overlook is it doesn't. To me, it never feels like I'm paying premiums because I never see them. They just come out of my paycheck. But your net cost for both plans is going to be the stacked result. So you had to pay for it and you had to pay some amount for care. But two of these plans have HSA money from 3M plus whatever you would put in optionally. So in this case, I'm not showing, I'm saying I'm contributing 0. So this is just the 3M money. So what I wanted to do is kind of have that, let me slide that back to 0. And you'll see the green will grow. So it's not really, you can't use it for whatever you want. Like you can't go buy a boat with your extra HSA money, but it is, you do carry it over from year to year. So I want people to know that that value is there. In your best case, if you don't have any expenses, you're going to bank that money for future years, and that'll be a nice buffer. And in the cases where you do use it, but you don't use all of it, I'm going through and I'm saying, well, what were your total expenses? And it's turning pink because I'm trying to represent that you're able to pay that with your HSA, so it's not sort of a felt impact. And then the green just grows, and so once the green grows to 0, then you start seeing these stack up here. So some money that you're able to pay with your HSA, and then the rest is going to be on you. And again, I don't know that these values are the best, but I wanted to have some representation of, in your best case scenario, how much better or worse off would you be on one plan versus the other. So maybe compared to Max wasn't the best, maybe I should have done compared to all of them or something and run all those numbers. But you can see, you would save a net of $2,400 to $4,000 if you spent nothing. So basically it would be way overspending for plan A. And then if it was your worst case, they switch a little bit, so they get a little bit closer, you're still saving. And if I played with the values, you'd see B sort of ends up being the overall winner. And there's some criteria for C that make it more appealing if you are pretty sure you're going to have low expenses. And in this case, I really did run out, I think all the way up to like $100,000, and A is never a better plan, so I still haven't figured out why they offer it. Which bothers me because it's the most intuitively luring because it has such a low, I think it's a $700 deductible. So, yeah, a lot of people I think are baited for that because they haven't looked into it. So I post this, and then somebody starts making the case, well, the HSA money is treated differently. So on plan A, if I'm contributing $2,000 a year to my HCRA, which you can't carry over, so there's some other nuances there, 3M gives it to you all in the beginning of the year. So even though it's coming out of your paycheck, let's just say $2,400. $200 is coming out of your paycheck monthly, but on January 1st they say, here, all the $2,400 is here for you to spend, and you're sort of paying them back throughout the year. On the other plans, you only get it as your paycheck withdrawal happens. So if you did $2,400 in January, you have $200 available to use, et cetera, et cetera. So somebody said, well, maybe you're in a cash flow situation where if you had something bad happen in January, you really can't absorb that and pay yourself back. You need to rely on that. So then, so I tried to simulate that, and I thought, okay, sure, like how bad would that, could that end up being? And I like to fine tune these, but the blue down here is trying to represent your HSA money. So as that sort of gets gobbled up, it's going to go to 0, and you're going to see the slopes of the expenses rise. So that's what happens over here. You used up your HSA money pretty early by February, and then you can get some line crossing here and there. There are scenarios where, see if I can pick one out. There are, maybe that won't work. There's definitely some scenarios where these lines do cross. So the blue line, for example, will spike up initially. Oh, maybe I need to have some HSA money in here. Oh, it's getting closer. Okay, so that's not a great example, but there's some plots like that came out when I was exploring, where yeah, he was right. There's definitely some scenarios where you're going to peak because you're having so much expense in the early part of the year and then pay yourself back. But it also helps you be a little bit more objective about it. I said, that's fine, but I just want people to be conscious that they're making that decision. So I want to say $600 in June so that I can lose a net of like $2,400 by the end of the year, because that's where you're going to land. So this is still going to show you your ultimate position. I still don't know that it's the most rational decision, but yeah, there could be cases like that. And then I just threw on one more to that. Well, what happens if all of the expenses come in January? So now you're seeing yourself on blue and green be sort of paid back throughout the year, whereas red had all that money available at the beginning of the year. So red is literally only rising because the premiums are so much more, because all the expenses hit here in January, and these are sort of coming down because you're actually reimbursing yourself, so your net impact is less. So I don't know that I talked about that the best, but it's a complicated financial, it's a complicated interaction, but this is one way. We just had some fun using this library to try to help others make some decisions. There's some great examples on the web. If you go to Shiny, there's a user gallery, and so people are kind of constantly updating what they've done. I guess one other thing to state, so this is running on, this isn't running where I thought it was. Anyway, this is running on an RStudio server, and what's really going on in the background is you're giving your input, it's sending that value to the server, it's updating based on your code, it's generating the plot as an image, and then it's sending it back to the web page. So it's not interactive in the sense that JavaScript would be, where it's all running locally and happening there, or in the JavaScript itself. It's just a static image that's sort of being sent back and forth. So for that reason, I found, you saw it took a little bit to load sometimes, especially this guy, which is now they kind of go to sleep. But that one, I think there's something like, it's a 68 megabyte CSV file. So there's a lot of data in it. I think it's like 840,000 rows, which isn't big data necessarily, but it can take a bit to chug along. And I found that our charts can be even a little bit slower, because I think there's a lot of things going on in the background where it's converting to maybe JSON or just doing a lot of translation there. So, all right. So yeah, maybe they were smiling because they're playing with Shiny, and it helped them make a better decision. So you've got your app, and now you want to share it somehow. If you are working with fellow R users, you can just send them some archive, and they can run it locally. Shiny Server is an option that's on GitHub, and you can run that on a local machine. Or there's a free account at Shiny Apps. So you can sign up pretty easily. There's a free version which does have some. Okay, I should have paid attention to that application limit. I think I'm at 5 now. So I can't do too much more, and I was a little hazy on this active hours. So if you guys all get really interested and start playing around with everything, they might kick me out for a month or something until my hours reset. I don't know. So that's another option for hosting publicly. And it's pretty neat. It used to be that you would log into the server in an interactive RStudio session and kind of create your files while logged in remotely. Now you can just do them on your own computer and then just type this command deploy app, and it just takes everything in that working directory and sets it up. And it will give you nice errors if there's like a library missing or syntax errors. I find that's a lot nicer because I tended to prototype a lot on my own computer, think I had everything right, then go to upload it, then you find some issue, and it's a little bit harder once it's running in the server to figure out what's going on, whereas you can debug locally a lot easier. So yeah, this is a tutorial for Shiny, which I think they do a really good job just walking through with some basic examples. And I think to reiterate one last time, if there's any point to this talk, it's not really that this stuff is that cool that I've done. It's more to give you hope that a mechanical engineer with very little programming experience can pick this stuff up, and I just think the tools have made it a lot more easy for me to leverage some of that, even though, again, I think some of the things going on in New York Times with D3 and those is definitely where I want to go, but this has been a nice medium ground. There's a mailing list. You can request things there. There's some Stack Overflow questions on things that I wrestled with and wasn't exactly sure. Winston Chang is another organizer for our user group, and he works with our studio, so he's very knowledgeable, and he's a great guy to have around Minnesota. There's links to the apps, and again, that's all in GitHub, and I included the app repository, so if you cloned this, you would be able to open it up in our studio and just run it locally if you want to play around. And then a little plug, not that I really have to make this plug here, this is more of a carryover for stuff I show at work of using open source software and reproducibility. So, has anybody heard of org mode? Emacs org mode? It's on. I'd love to give a talk on that sometime. That's actually what I write everything for work in, and you can. It's similar to our Markdown in our studio, where you can intersperse, I guess, what I call prose. So technical writing, and then say, as a result of this, we can take a look at the following chart, and then I can have our code right there, generate my plots, and include them in. Generally, I do PDF, so it's going through LaTeX, but it's a very Markdown-y syntax, so you don't have to learn all that either. And then Beamers tends to be pretty obvious, so I tried to hide that from you. This is a Beamer presentation. Yeah, that's what I have. I don't know if there's any questions, or is that all helpful, interesting?
This is anecdotal because of this slide, but are you actually running Arch Linux on a laptop?
I had a little bit of trouble. I came early, went to present, and it was cutting I could do a dedicated monitor, and it showed my full slide. But then when I tried to duplicate so that I could see what the heck I was doing, it didn't, so then I had to rely on rebooted Windows 7,
Gotcha.
the dreaded.
Well, my follow-up question was, how many hours a week do you devote to keeping your laptop working with Arch Linux?
Hardly any.
Really?
Yeah. It's one of those things where it can kind of build up. You'll update some things in some config files, but it's pretty smart about that, so it won't overwrite the working one. It'll just say like,
Gotcha.
fstab.packnew or something, and that kind of tells you, it thinks it should be updated, but it's not going to force you to until you get to it. There have been many hours, but yeah, I'm trying to do less of that, but yeah, enjoy it. Yeah.
So how chatty are we talking about for all of those images? Like if you had a fair number of users, let's just say 100 users internally that wanted to be able to pull up and refer to this,
Right.
how much traffic?
Yeah, that's a really good question. I'm actually not sure on that, how it can.
But they are flat images and they could probably be compressed.
Yeah,
Transient.
I'm assuming only because I've used our studio locally to make HTML that they're PNGs, and if you do stuff locally with our studio, it's not really the image. Like it's not like an image tag. It's literally like the image is in the HTML, if that makes sense. I mean, there's must be some way to take a PNG and take its binary data and actually embed it in a page. So if you sent the HTML and had no image at all in the directory, it still would load. So it's one and the same with the HTML that it generates. So I don't know if that's how it's doing it or what.
It embeds them in.
I haven't found the PNGs to be that big, even for pretty complex stuff. I do often tend to generate PDFs and maybe some of that ramp data. That might be like 1.5 meg for some of the more data-heavy plots I've made. But I'm thinking the PNG might be like
That's stuff
600K.
you can't easily cache.
Yeah, not with this because you're kind of constantly changing it. Yeah, our studio, if you want to end up using Markdown or working within our studio, there are some, you can have code blocks and have a cached option. So just say cache equals true, and it won't rerun it as long as you don't change the code. So I think it stores like a hash of the code block, and if that matches, it won't rerun. So that's nice when you're exporting.
Yeah.
It just takes a long time to check through a bunch of blocks. So, yeah, I think ours is cool. It is clunky. I want to learn Python, but for now it's working well. And
We've got a user group.
what's that?
So we've got a user group.
Yep. There it is. And I just,
I was kind of curious. I saw with the laser data, there's quite a bit of jitter in there. Is that legitimate jitter, or is that just from just random errors and you can smooth that out?
It would be, that laser sensor is, I mean, I've looked when it was sitting, before the move started, so that's kind of what I did is I had an amount of lag for every some lag and then some stop just sitting at the final position.
Yeah.
And it was like dead on, I mean,
Really?
within
Okay,
point,
so it's actually
point
the
zero one.
motor that is causing it.
Yeah, yeah.
Interesting.
And I haven't decided if that's a big deal yet. It's a ball screw, and I'm wondering if that. I actually was thinking about that recently. Like, gosh, does that periodicity translate to the flights on the screw it's using? I don't know. I'm inclined to think, yeah, 10% isn't great, but it's for what it's doing. There's some more a lot lower speed testers at 3M that probably don't have that, but I think the pitch on the screw is a lot finer. So. Yeah, and that's all stuff that comes out of, the biggest thing that came out to me was the overshoot on some of these ramped mode, or the fastest. And again, I'm sampling pretty bad here, so this will look not necessarily smoother, you just see a lot more of the noise as it's kind of jerking along. But this bothered me a lot more, you know, because it's going up. And I think this is even higher in the raw data. It just depends on, since I'm doing a random 250th.
Oh, sure. Is it like feedback controls in there, or?
No, I don't think it does, but I want,
That's
I
right.
I definitely passed that along to the guy running it, because my time is so short here. I mean, you're seeing him done, basically I'm decelerating in a half a second. So if I'm spending 2/3 of that overshooting, undershooting, and then settling, I'm not really getting the data that I want. So if you can't fix it, then I just probably won't use that test. But yeah, that definitely was a insight that came out of starting to look at that.
Good mention of the archive exports are pure JS and HTML. Is there any way for it to like use JS or whatever to provide a situation where that export also does some of the mathematics, or does that all have to just be static data?
I think you can. So when I looked into how to customize them, I see that there's ways to pass, you know, if you wanted to change your scale values, you know, then you can kind of go into the more common, you know, equals function D, return D times whatever. So I think, yeah, you can absolutely reference that. And maybe I should clarify, I don't know if you get a pure, I don't know if you can just copy that CS or JavaScript code and then embed that. So far from looking around at his chart, you know, he talks about different ways to share it. There is standalone, but it talks about publishing it somewhere. So I haven't really played with that. And then Shiny, and then Slidify is another, he mentions that somewhere. Slidify is a way to turn R Markdown into a presentation, kind of like I'm doing with Beaver. So